week 9, we are covering chapter 7. We need to know what is the difference between AC, DC, and electrical distribution. So in the lab, when I had you use the multimeter, we have to measure alternating current. We measured DC current. I had you measure the battery. I had you also measure a charger. And I also had you measure 220 volts, single phase, 208 volts, triple phase, three phase. So we saw it has different receptacle and it has different phase. What does phase mean, Benny? Somebody? Yeah.
Stages?
No. Phase. Single phase, triple phase. What's phase? No.
Depends on the current.
How many currents are there?
Okay.
So single phase, one current going through the voltage. Three phase, three currents going simultaneously in the wire. We'll talk about that. So if you don't know, that's fine. But we did mention it lightly. We will reiterate and talk about that more. So we'll talk about the difference between direct and alternating current. Probably by now you have seen how they are different. They are not interchangeable, but we can change from AC to DC. In quiz 2, I asked you what kind of current do you have in your car. What was it, AC or DC? DC. DC is direct. And you also saw if you use your multimeter and you put it in VAC and you go measure DC, it's going to give you the wrong measurement. And when we looked in the multimeter, we had V, that's AC, right? And V, DC, straight line, and this one is the alternating. So the difference, one of them is always constant, always going in a straight line, and the other one looks like a wave, it's a sinusoidal wave. How alternating current is produced? It's very similar to how DC is produced, but there's small differences mathematically, and it had some differences. Difference between single phase and three phase power distribution system. Single phase and three phase are more currents. What would you think we need three phase for? Huh? Yeah, higher load. If you have a huge motor, you want more currents going through it, more flow, more current. If you work in a factory, industry, or a mill, probably you have more than one current going through the power, and usually you can't take one current out of it. But when you do power distribution for residential, it's going to be single phase. For industrial, it will be three phase. If you go to commercial buildings, like big commercial buildings where they have huge compressors, probably you will need three phase. So think of phase as more current, more power, more pushing power between equipment. So power distribution system, we do not notice power distribution, but now probably you start noticing that. How is the power coming into your house? Probably underground wire or an aerial wire. Probably if you go to your house, you see a big cable coming into your house. If you go to the neighborhood, there is in every district, there is a distribution center. How much power is going in there? And it will make sense that the power will be higher at the distribution center because you have more than one house connected to it. And how do we produce power? How much power is being produced? It's a lot of voltage. So it's going to be different kind of distribution. And the farther we go, what happens to the voltage? It drops. Yeah. It drops. However, we want the drop to be consistent and systematic. So I'll set your house 105 volts, 90 volts. Now I want to be 120, 118. The fluctuation has to be limited, so it will not be very big. Otherwise, it will affect your equipment. And common voltage system. You don't have to know too much about this, but you need to know they are different and how to distinguish between them. We're not going to work on. We're not electricians, so we're not going to do different systems. But you have to recognize what is three phase, what is one phase, so you don't do the mistake of wiring single phase into three phase and so on. And probably if you work with commercial buildings, you will know how to wire three-phase compressors. To identify them is not a very big deal. You don't have to remember that, but I'm going to mention for information so you'll be familiar with the names if they ever come up. But I will not test you on this, so you can just sit back and relax and just look at a different system, and at least you have heard about it. So when somebody comes to you and tell you, oh, this is wired based on the old Y system, so okay, you know it has something to do with voltage, okay. But just to be familiar with it. So we said current from the first class is the flow of electrons in a wire, in a conductor. We have DC that goes in the industry, and we also have AC. So if we will look at the production of power in a graph, DC direct current will be either positive or negative, but it's going to be constant. This is DC, say 12 volts. That is DC, this is 0. And if we have AC, we can have AC 12 volts if we want to. 12 volts positive, 12 volts negative, and the voltage will go up.
Fluctuate.
And the fluctuation is equal between the plus and minus. That's why if you put the multimeter on DC and you plug it into the wall, it will start flickering back and forth between the amount of voltage. So it will go up and down all the time between positive and negative. And we call the time when it goes from here to the beginning, we call this what? A cycle. So this is a cycle. So start from 0 and we came back again to 0. That's a cycle. And how many cycles do we do per second? It's called, help me out here, frequency.
Yeah.
Cycles per second. Also known as hertz. So how many times do we go back and forth in 1 second? So how does that work? So everything usually go in cycles, back and forth. If we have an alternator that goes in circles all the time, and this is a wheel that's moving, if we were to transform that into a cycle, we have this as, what degree is this? 90? No, this here is 0, go up, 180, and this 270, and this again becomes 360. You don't have to know this. Just to explain to you how we come up with this sinusoidal wave. Who heard about sine and cosine in trigonometry? Sine and cosine is a function based on this coordinates. So we have 0 degree here, and we keep going up. These are the coordinates, and how do they transform into a wave? Everything is transformed into a wave. Radio waves, cell phone waves, TV waves, everything is a wave. Can be transformed into this cycle. A wheel going into a cycle. So, to explain this a little bit further, if you put in your calculator, you have a calculator with you? If you put the sign of 0, what do you get? you'll get 0. What is the sine of 90? Try it. I get 1. What is the sine of 180?
0.
0 again. What is the sine of 270?
Minus 1.
Okay. So somebody thought, yeah.
What does that say right there? Sine?
Yeah.
S-I-G-N?
It's I-A-D.
S-I-N.
So plus and minus value of 1. And this is where we get the tips of all these. So we are all going to go back to 0. And this is going to be the plus 1, minus 1, up and down. And the value is a factor you can put into the wave. So we're going to go 0, 0, 0, 0, plus 1, minus 1, and so on. So this is how we can transform the factor of this circle into a wave. I'm not going to go too much into the math, but you understand now why do we come up with this wave and how does it translate from an alternator that goes in circles, now we have a wave. How does it happen? This is how it happens. It transforms into a wave, even though it's cyclical, plus and minus 1, and 0 and 0. Okay, enough of this. So most current is produced using AC current. Was it always like this?
No.
No? In the beginning of the 19th century, they used DC current, where you have a generator next to each house. And you have DC current. DC can run lights, it can run motors, it can run a fan. But what was the problem with DC? No, it can, you lose that, yeah, you lose amount of power. Yes, over distance.
That's what I mean.
Yeah. So every house has to have their own generator on the spot. Otherwise, it's not going to work. So that created a lot of problems. Every house will have a generator. That's kind of dangerous, you know. Everybody have to take care of their own generator. And only the big, rich houses will have generators in it. I don't need to have a generator to have some power. So earlier on, I think in the 1920s or 30s, maybe earlier than that, Nikola Tesla thought of the AC current. Okay, there's a way that I can transform a wave further without a lot of losses instead of DC over distance. And we said whenever we run current through a wire, what happens to it? The wire gets heats up, and there's magnetism, and you're using the wire. You're using the current. The voltage will decrease eventually until you have nothing. That's why in the car it's okay to use DC because it's a very small distance, not that long. And even though sometimes if you have, who have a sound system in their car, like huge sound system? I heard in the street. I heard the big vibrations. So for those who are into like installing huge radios and subwoofers this big and whatever, what do they do usually? The battery is not enough anymore. They put a second battery in the car, and you have to upgrade your alternator. So you need more power for that because again you're consuming more power. There's more wires, more amplifiers. Amplifiers do consume a lot of power. So in that case, it's not enough. So you need AC. So Nikola Tesla started with the AC current, and there was a big, I don't know if you heard about it, a big war between AC and DC. Thomas Edison wanted to prove that DC is the best way to go further, and Nikola Tesla did not like that, and they had a big war between Westinghouse and General Electric. Do we go with DC? Do we go with AC? And again, it was a big war at that time, which for the layman person, we don't care. We just want electricity. We like power. It's awesome. But for them, it was a big deal because there was a lot of money involved. And again, equipment will follow. If we have all the appliances in the house in DC and AC, nobody will use AC. So there's a lot of big costs and big losses in sales and revenue. So it went on. At the end, they realized that AC is the best way to transmit power. And they started, who ever been to Niagara Falls? Niagara Falls? American side or Canadian side? American side. Whose statue is there? There's a big statue of Nikola Tesla. and a power
I only
station.
went to the boat and then on the top of it.
In the top, there's a museum there, and Nikola Tesla
Oh,
sitting
yeah.
there. And that's why it was the first power station that submit powers all the way to New York City from Niagara Falls. This is how far it goes using alternating current as a methodology. So for us today, everything is used. All the equipment we have are alternating current. What do we have as DC current? Flashlight, your multimeter, small equipment, your handheld equipment are DC because they have battery, but most power that plug into the wall are AC. That makes a lot of work. Some stuff require DC for chargers, but that's about it. So everything else we have is AC current. So AC equipment is cheaper and more trouble-free than DC. Why is that? It's the way how the motor is constructed. Remember when we saw that corny video? We saw that in the DC there's small little pads that alternate called, what was it called? Commutator. Because with DC you have to reverse the cycle so you keep things moving. With DC you don't, because it's reversing by itself. So there is no touching. In old cars, the alternator used to use DC, used to produce DC, and every once in a while you have to go and change, what do they call them? Brushes. These brushes touching the commutator, after a while they get worn out. Who's doing a hand drill? So if you look at the hand drill, if it's a DC, right? You will look inside and you'll see small little brushes made out of graphite. After using the hand drill for a few years, you'll need to change those graphite because they touch the commutator with an angle, so it will keep alternating and keep it running. AC is easy to produce according to the book. Again, for a lot of touching, and because it's natural to circle things around, move things around, and change that cyclical motion into an AC current. Meanwhile, if you want to use the same thing with DC, I'm going to only take the tip here. So for DC, I'm only concerned with those tips here. There's going to be, that's the power I'm having. Meanwhile, here you have power continuously alternating, and you can use that accordingly. The flow alternates, represented by a sine wave. That's a sine wave. Everything that is represented by a wave is a sine wave. A sine wave is used for radio, for transmission, Morse codes, always sine wave. Cycle, two alternations, each changes in direction, so you go up, down, and up again. You start, you end where you started, that's called a cycle, which in here, going around completely, is a cycle. So this, one cycle. Frequency, number of cycles per second. How many cycles per second do we have? What do we use for frequency? Hertz, and how many?
What was it, 60?
60. That's the normal. We can go a little bit further at 58, 61, but usually it's 60. 60 is solid. This is a representation of the sine wave, again with the north and south pole of an alternator. Again, you have the circle over here, and you have the whole thing going in a wave. If you work in networking, electronics, you will do that a lot. How you transform things in a sine wave. Transmitting is in a wave, and waves goes really further. AM radio, if you remember that. Does anybody remember AM radio? I think it's still
AM
hot in your
radio?
car. Isn't that dead yet?
AM radio?
Yeah.
Yeah, they have some stations that are like.
Yeah, very weird station. So AM radio does not go further. What does AM radio mean? Yes. I'm very impressed, man. Good for you. So AM is amplitude. What is amplitude? It's this, how far does it go? So amplitude then I'm gonna have to spell that. Amplitude modulation. So how do I modulate the amplitude? This is the amplitude. So I'm gonna go with something like that. So I'm modulating the amplitude of the wave to send signal. So what about FM? Frequency modulation. So I'm going to keep the amplitude constant and I'm going to change the frequency. So it's going to be something like this.
That's FM?
Yeah. So smaller, denser, and
This
larger.
one go like small and then
Yeah,
go to
yeah.
big.
You modulate the frequency instead of modulating the amplitude. That's the amplitude. And everything that's been sent is between frequency modulation or amplitude modulation. And FM, when it came out in the 90s, it became very common, FM. It was clear voice, very clear. You don't have to hear those distortions, because you pick up more distortion when you do amplitude modulation. You get all those weird funky noises. You can pick up some alien waves sometimes. There are some areas where you can pick up a lot of waves. It was big to Mexico. There's a dark, what is it called, that area? There's a region there where there's no radio signals anymore.
Dead Valley.
Huh?
Dead Valley.
Yeah. Dead Valley? Yeah, it's Dead Valley.
Death Valley?
Nothing.
California.
Huh?
I would say Death Valley, not Mexico.
Death Valley is in California or Mexico.
No, it's in California, or, yeah, it is
I mean,
California.
there's an area in Mexico that a lot of scientists go to visit. Yeah, no cell phone will work there, no radio signals, nothing. It's a very dead area in Mexico. I forgot what it's called. Death region or the dark region or whatever, Devil's Alley, something like that. But it's very, very creepy. Whereas nothing works out of these frequencies. Now we are here. There's a lot of frequencies around us. Nobody knows. Nobody knows.
Aliens.
Could be. Who knows?
That's how people disappear.
I believe in aliens.
Yeah, because how is it possible?
I'll stop talking.
I believe too, because how is it possible that we're the only species?
Does that look normal to you? So, anyways, around us now there's a lot of frequencies, right? We don't feel it, but they're there. Again, I'll talk about that more when we do lighting and heat system design, how some scientists found that those waves have effect on our psyche and our moods. That is a possibility. It's not for sure. Yeah.
I heard, especially if you're near a cell phone tower.
Yeah.
Yeah.
You'll realize that some people are very sensitive to cell phones. Like they get migraines and headaches because of cell phones.
It's true. Did you hear about what they said about 5G?
About, yeah, 5G is not good. Also, those recent research on NPR about those Bluetooth headphones, they give you a lot of headaches and they give you cancer because they're transmitted to each other by Bluetooth. So we should be careful, even because these things we do not see, they are all around us. And there's a lot of cancer. I think, yeah, it can lead to cancer. The ones that are separated, because they're transmitted to each other through your head. So, as I said, it's a possibility. So waves are interesting, waves are scary, a big field of study. Anyways, that's not our concern, but it's interesting to know. All you need to know is AC and DC, what equipment goes where, frequency, and so on. There's a YouTube about how DC current, I'm not going to watch it now, but you can watch it if you want later on, how does AC is being produced, or what is the difference. Distribution. So, power generation station, that's when they produce things in gigawatts or megawatts, or gigawatts, I don't know what they call it. But anyways, most plants are producing with megawatts. How much is your house consuming per hour, on average? Kilowatt, 1 kilowatt.
1 kilowatt an hour?
Yeah.
Not bad.
Yeah, it's not bad, but it's the average. You want it to be more, or I mean less. Sometimes you're gonna have two kilowatts, sometimes you're gonna have zero, and if it average to 1 kilowatt. So our power station usually is in megawatt, 15 megawatts, so it means it can produce electricity for 15,000 house, which is pretty decent. So this is your power station, big alternator here, coal, nuclear, whatever heat you can produce to make steam and move a turbine. It goes to a step-down transformer from megawatts to kilowatts, 100,000 watts. Then it goes to big cables. Let me show you the cables. I don't know if I showed you the first time, but so these cables are huge. This is, look at the insulation, wax, plastic. I'll pass it around. This is a slice. So this is one of the cables that goes underground or aerial wires with a lot of volts towards it. This is probably 4 zeros or something. It's very huge. So some of them go underground and some of them are aerial. Why do you think some of them are underground, some of them are just on poles? What do you think? Depending on the demand. It's easy to fix a wire when it's hanging than to bury it, dig the street out, and put cables in there. But what is the problem with aerial cables?
You can't have them everywhere.
Yeah, you can't have them everywhere. What else? Especially in New England here.
Get knocked down.
Yeah.
Fall.
Yeah. The weather changes, a tree falls on them, and they get knocked out, and it takes a few days to fix them. And when they get knocked down, they also cause a power outage and cause a hazard. But it doesn't justify for us to put underground cables unless there's a huge building. Usually in cities, like you go for downtown Springfield, there is no aerial cables. That's very dangerous. But if you go a bit further, every house will have an aerial cable. Again, to make things a little bit easier. And also, if we have gas for heat, usually gas is going to be underground.
Yeah.
Do we want to mix gas and
No.
and power? So that's a no. Let's just keep one underground and one as aerial. But they get really messy. If you look for picture in South America or the Middle East or some European countries, whenever house have its own wire, it becomes a cobweb. It's really hard to know which wire goes where. So anyways, we have electricity poles. Again, who was saying, yeah, something about the waves, that you should not be living close to a cell phone tower, and now it's illegal to live close to some big transformer. They made some laws that you have to be a certain distance, because again, there's a lot of frequency and humming coming out of these things, and it could affect your health or well-being. So if you go move into a house that is very cheap, you better wonder why. There could be a train coming every 15 minutes, airlines, something like that, or next to, I don't know. So be careful. Look at those. So this is 50 kilovolt, 50,000 volt, that's substation again. We keep stepping down. In here we have 50 kilovolts, which is step for a whole district. And again, we go into aerial with wooden poles, and it goes down to, some of them go to commercial. Those are 3-phase. Commercial consumers, or they get 3-phase, more voltage. And for residential, we get 220 to your house. This is similar to the power line I have coming into my house with 220 volts. So every house gets how much? 220 volts.
Holy shape, looks good, man.
Thanks.
Come.
Change is good. It's my winter look. So if we look at this in your house, how many volts coming to it?
220.
220. Hot, and neutral. Or ground, yeah.
Quick question.
Yeah.
Can you draw a paper on that?
Huh? Yeah, sure. How does it connect? What kind of circuit breakers are there? They got involved. They got really. Some of them are now even are smart boards. We'll send you a signal to your phone and tell you which board, which one is being overloaded. So this is our power distribution system, and a lot of states now, including this state, they're working on something called smart metering system. So back in the day, somebody will come to your house every month and look at the meter. So they do the meter reading, then they charge you on it, which is still the same way. even now for gas, and they will guesstimate, then they overcharge you, then they refund you later on. And so you have to, somebody has physically go in there. Now they have smart meters, but again, it's a legal matter. They have them in Texas, they have them in Maine, which means that you have a smart meter that's like LCD monitor that send a signal to your power provider. They tell you this guy is using too much this and this power for this amount of time. They will come and check why are you spending too much power. They check your equipment, they check your wiring. Maybe the house is wired differently. Maybe you pay for your neighbor's equipment and you don't know about it. So smart metering is a good idea. Also, with smart metering, it tells you what is the cost at that time. So you decide, do I want to turn my dryer now or maybe midnight? So again, you know there is peak power, right? Like now nobody's home, so this is low time. But who's consuming power now?
Everybody at work is cool.
Yes, everybody at work in school, a big industries are working right now. So there is some kind of alternation. Nobody's using electricity now, but everybody's using industrial work, a lot of high demand. So they tell you if you program your dryer or your oven or your laundry or your washer, you can program it to turn when the power is 10 cents a minute. So I will save some money over time. That is called smart metering. Also, when the tree falls in a line and one of the line is out, it will pinpoint where the line is so they will come quickly and fix it. They were sort of doing that much better than before. Remember a few years ago when we had a storm and we were without power for like a week or so?
Yeah.
And I had to eat all the meat in my freezer quickly. So I made a big party because it's gonna spoil, you know, and depending on where you are and if they're gonna find it or not, it's very challenging. So this is basically how power is transformed. For transporting power, for transmission, we use AC current. And again, the change between AC and DC is very doable. We use something called rectification system. Write that down because we're gonna talk about it a lot.
Oh, yeah, so.
Rectification system changes or transform AC into DC and DC into AC, and it's a very good way to have two power for you. Most electronics, they use AC or DC. Huh?
Most electronics is
It's low voltage, but it could be either AC and DC, and you can see inside the board. You can plug in AC, but inside the board they do DC because we try and do control. So we cannot confuse the control by plus or minus. We want either plus or minus. So you always see a capacitor and a rectification system, but inside the board is DC for the control. Okay, I'll stop here. I think that's enough for today.